Hey guys, welcome to Conceptual Geometry, lesson 3.10, Properties of Trapezoids continued. Super quick review, we've already established these shapes. A regular trapezoid, nothing very remarkable other than the fact that these two sides are parallel, has exactly one pair of parallel sides. And at the same side, we call them transversal angles because this is a transversal. Same side transversal angles are supplementary. So these two add to 180. Those two add to 180. We're mainly going to be dealing with isosceles trapezoids. They're a little bit more unique in that the opposite legs, so the non-parallel sides, are congruent, as you can see there. Also, base angles are congruent. Now, by base angles, you have two upper base angles and two lower base angles. Those are both congruent. Then this property still holds true. The same side transversal angles are supplementary. Another property of isosceles trapezoids is that the diagonals are congruent. They don't bisect each other, but the length from D to B is the same as the length from C to A. Okay, let's finish up our last few examples. Here we go. We left off on example 4. Given isosceles trapezoid MJKL. All right, so there's a lot I know. These two sides are congruent. These two angles are congruent. Angles J and K are congruent. And the diagonals are congruent. So they're going to give us one pair of those sides. It says here JM is 7x minus 5. So JM is going to be this side. KL is this side. It's pretty easy to represent in the diagram. 7x minus 5 here, and that's 44. And it says find x. Well, this is kind of a simple problem. I know those legs are equal, so 7x minus 5 equals 44. Let's add 5 to both sides. 7x equals 49, divide by 7. X equals 7, and that's all I had to find x. All right, again, an isosceles trapezoid, MJKL. Measure of angle JKN. JKN. So that angle right up there is 32 degrees. Let me put that in. That's 32 degrees. Find the measure of angle NML. NML. So I need to find this angle down here. Put an X. Remember in class we talked about alternate interior angles. We said when we have two parallel lines cut by a transversal, so there are parallel lines, there's a transversal. Alternate interior angles are equal. And one of the ways you can recognize that is by looking for a Z. And in a Z, those two angles are equal. So this one right here, X equals 32 degrees. Not a whole lot of work to show for that one. Okay, we're going to make up for those two easy examples with this last one right here. It's going to be challenging. It says the lengths of the bases of an isosceles trapezoid are 12 and 22. If the length of each of the legs is 13, find the length of the altitude. So first thing I need to do is draw an isosceles trapezoid. I'm going to use this shape kind of as a guide. So I need to sketch something that looks roughly like that. Okay, so take your time when you do this. Don't rush. Now, my drawing is not perfect, but since it's isosceles, I know these two legs have to be equal. I also know these angles have to be equal, and these upper base angles also have to be equal. It doesn't mention anything about diagonals, so I'm not going to clutter up my diagram with diagonals. But I do know the bases are 12 and 22. So these represent bases, the parallel sides. The smaller one's got to be 12, the big one's got to be 22. Okay, let's put that in, 12 and 22. And that says the length of each leg is 13. Well, here's a leg and there's a leg. Obviously, it's isosceles, so those two are the same, and those are both 13. So I can fill that in. Well, how am I going to find an altitude? First of all, what is an altitude? Well, an altitude does this. It comes down perpendicular to the base. So I can draw an altitude anywhere I want. These are all altitudes. Well, when it comes to an isosceles trapezoid, one altitude sort of makes sense, dropping it from that corner. So I want to find x. So since this trapezoid is isosceles, what I want to do is I want to create a rectangle inside this trapezoid. So if this side here is 12, I know that side there is 12. Okay, well, let me sketch that in then. So this distance is 12. Well, how does that help me? What I'm really going to do is I'm going to use the Pythagorean theorem on a right triangle. And I want to find this side here. But in order to find this side and to use the Pythagorean theorem, I need that. Well, to get this length is really a simple calculation. I know this distance here is 12, and I know this whole distance is 22. So what I'm going to do to get this piece here is I'm going to take 22 minus 12, that gives me 10, but then I have to split that with these two sides. So then I do 10 divided by 2, and that gives me 5. So I know this piece here is 5, and that piece there is 5. So I'll fill that in. That's 5, that's 5. This is 12 here. So you could add them up. 5 plus 12 is 17. 17 plus 5 is 22. Okay, so now I can use this triangle, my Pythagorean theorem, and say x squared plus 5 squared equals 13 squared. X squared plus 5 squared equals 13 squared. I'm going to subtract 5 squared from both sides. Use your calculator. That gives you 144. And then finally, we just have to take the square root, and x equals 12. That is the altitude, that's this length right here, of that trapezoid. Please make sure you know this question. You will see it again on the homework work session review, and it will be on the exam. Kind of a challenging question. There aren't too many challenging questions when it comes to isosceles trapezoids, but this is definitely one of those applications. Okay, guys, that's all I have. That's the last day of notes. Please reach out if you have any questions whatsoever, and thanks for watching.